I'm going to go through with you how to do one motor programming using the Cortex and using the Robot C program that is on the laptops in the classroom. So they're the hero books. You cannot do Robot C on your Chromebook. So the first thing you want to do is locate Robot C. Please do not open Graphical Robot C. That's a drag and drop. You actually want to open up Robot C. The graphical one actually says graphical in the name. We're not using that one. We're actually using Robot C for VEX Robotics. When you open that, you're going to want to start a new file. And when you start a new file, you want to go to Robot. And the first thing you're going to do is go to Platform Type. And you want to make sure that under Robot that you have VEX 2.0 Cortex highlighted. And then once you actually have that highlighted, you want to go to Platform Type and make sure that Natural Language PLTW is also highlighted. You have to make sure that both of those are on for you not to get errors in your program. So every time you open up this particular program, you have to go to Robot and select those two items. And then there is also a third item that you have to select that is also under Robot. You have to select USB only. It's under VEX Cortex Communication Mode, and it's USB only. Those three items, every time you open up the Robot C program, have to be highlighted, or you'll get error messages either on your Cortex or you'll get it in your program. So always check for those three items. The next step that you want to do is learn how to save your file. So we're going to go to File, Save As. Don't hit Save because you'll be saving on the Hero book, and I can't guarantee that it'll stay there. So go to Save As, and you're going to scroll down until you see Strongsville MS Common, standing for Strongsville Middle School Common Drive, and you want to open that. If you're in Mrs. Gasparo's class, just look for her name, her class period, and the year. If you're in Mrs. DeLong's classes, just look for DeLong's classes and the year that you're actually in. And since I'm doing this Mrs. DeLong and not Mrs. Gasparo, I'm going to double-click open DeLong's classes. And you're going to save your file in here by going to File Name, typing in your last name. So my last name's DeLong. So you and your partner's last names. And then also put in the file name what you're actually making the program for. So you can actually remember this is because we do a couple projects with motors. That way it's easier to find. So your last name and what you're actually using the program for. So one motor for, let's say we're using this for the dragster. Then hit save. And then at the top here, it actually says what the name of your file is. Now, we are just doing one motor. So we are going to go up to Motor and Sensor Setup. And along the top here are some tabs. So if you're going to do one motor, if you have a 3-prong motor, you can put it in ports 2, 3, 4, 5, 6, 7, 8, or 9. If you have a 2-prong motor, you can only use ports 1 and 10. So I'm just following along the folder that we have that also is the same as this video. It is actually for port 1. It's actually for a 2-port motor. But I'm also going to do it for a 3-port, so I'm going to put it in a port 2. And because it has 3 prongs on it, we're going to put it in port 2 or port 9. This tells you where you're actually going to plug it into your Cortex. So when you're looking at your Cortex on the side that says motors, whatever you put into this particular part of the program will be the same place you plug in your motor in, actually on the physically on the cortex. So we're going to name our motor. We're going to just call it motor 1. If you have more than one motor, I usually just say motor 1, motor 2, motor 3, or if it's used for a specific reason, you can actually put like, claw or wheel or rear wheels or left wheel, or, but since ours is just a basic one motor. And then we're going to select no motor, and then we're going to go to drop down. All the motors that we use are VEX 393 motors. Now, the other option here that you use at times is called reverse. If you actually want the motor to go the opposite direction, you're going to highlight this, or you're going to unhighlight it. So it depends. You're going to have to test it out to see if it's actually going the correct direction that you want it to. So that's the first thing, and we're going to hit apply. And then the next item we're doing is the digital sensor. So we actually have a switch that we're going to use to start the motor. So when we click on the VEX Cortex Digital Sensors tab, we are looking at digital 1 through digital 12. You can plug in the bump switch, or you can plug in the limit switch into any one of these, digital 1 through digital 12, and it doesn't matter. And that's actually DGTL, even though the L looks like a number, it's digital, and then the numbers 1 through 12. So we happen to be using a bump switch, but you can do a bump switch or you can do a limit switch. It doesn't matter. They both do the same thing. And I'm going to go ahead and plug the bump switch into digital 12. So I'm going to call it a bump, BUMP switch. And both the bump switch and the limit switch are actually touch, because you touch them to start them. So they're both touch. And so we say bump switch, touch. I'm going to hit apply. I'm going to click OK. And then the information that we just put in the motor and sensor setup is actually at the top here. So these are the names of what we typed in of our switch and our motor, and these are the ports that we plug them into. Now, the next thing we're going to do is we're actually going to write the program. So task main starts the program, and there's a open curly bracket. And the open curly bracket and the closed curly bracket are there automatically for you. It's saying type the program in between there. So I'm going to hit enter. And the first line of code I'm going to do is while parenthesis 1 equals 1 parenthesis. Now, what that does is that actually sets up a continuous loop. Because 1 is always going to equal 1 in the math world. So it just sets up a loop that anytime you turn the cortex on, it's going to run this program. And then underneath that, I'm going to hit enter. I'm going to do an open-ended curly bracket, which is actually right next to the letter P on your keyboard. You have to hit shift and then the open-ended curly bracket. And then we're going to type in the term until touch parenthesis bump switch parenthesis and then semicolon, which is right next to the letter L on your keyboard. Now, if you notice, there's some things that are capitalized, there's some things that aren't. You have to type in exactly the same letter case. So up here, I used bump switch and I used a capital S. That meant in my program, I also had to actually write bump switch with a capital S. Until touch, the T is actually capitalized in the command, so I had to actually type a capital T for that. If you actually don't use the right letter case, you will get an error message. So spelling and grammar do matter. Spacing, however, does not matter. So I'm going to hit enter. My next line of code is going to be when I touch the bump switch, I'm going to start motor, parenthesis, and the motor that I'm starting, what I name the motor, again, at the very top on line 2, I put the name of the motor as motor 1. You guys, motor is MOTOR, not MOTER. So motor one, comma, and then next to that is going to be the speed. So the max speed that you can do a motor is 127. I'm going to do a close parenthesis, and I'm going to do a semicolon. And I'm going to hit enter. The next line of code, since I've started the motor, I have to do a wait command with a parenthesis, and then I'm going to type in how long I actually want the motor to run. So it's in seconds, but you don't actually have to type seconds. So I'm just going to type 5 and say that it's going to run for 5 seconds. I'm going to close the parenthesis. I'm going to put a semicolon at the end. I'm going to hit enter. And then after 5 seconds, I have to stop the motor, parenthesis, and I'm going to type the name of the motor that I want to stop. And you don't have to put a number there because you're doing stop motor, so you don't have to do 0. So you just do stop motor and then motor 1, semicolon. And then we have on line 8 here, we have an open curly bracket under the while statement, under the loop. So we have to actually close that. So we're going to go here to line 12, and we're going to close that particular curly bracket. So this open one on line 8 has a closed one on line 12. This open one on line 6 has a closed one on line 16. It doesn't really matter that these extra lines of code are there. You can actually delete them or leave them. The line numbers don't really matter. They're just there so you could refer to which line you're actually working on. Now that we actually have our code typed in, we have not saved this while we've typed in a lot and we've done a lot. So remember, we went ahead and did file, save as to name it. Now, since we named it and we put it in the middle school common drive, all we have to do is hit save and it'll update our folder, our file. So now that we actually have a program, we're going to make sure that there's no mistakes. So we're going to go through that. We're going to confirm on our Cortex that we plug the bump switch into digital 12 and slot digital 12. And then we're going to confirm that our motor is plugged into the motor port 2. So make sure you're putting these in the correct locations. Once you do that, you're going to connect the USB cord to your Cortex into the laptop. You're going to plug in your battery. You're going to turn the Cortex on. Now, this is something that you don't have to do every single time, but you can download the firmware. Firmware is kind of like an operating system. I do it to erase all the programs that are there. Or if we're having some trouble, you can do download firmware. However, you don't have to do that every single time. You can do it maybe once every 10 times or 15 times that you download it. You don't need to do it every time. But what you do need to do is click compile program to see if you have any errors. So if you notice down here, it says that it's been saved to the Z drive where it was in DeLong's 2021 all classes. That's where we want it. Here's the name of our program. And that we compiled it on April 4th at 8:15 in the morning. And then there's no errors underneath it. So let me show you what an error might look like. So let's say we accidentally on line 8 did a lowercase s instead of an uppercase s to have it match what we put into our sensor. And we hit compile program. It's saying on line 8, there's a warning that we're substituting similar variables, a bump switch for bump switch. So it even says check spelling and check the letter case. And as soon as I come up here and change it back to what it's supposed to be, which was a capital, and hit compile program, then the error message goes away. Or another error message could be, let's say you forget to type a semicolon at the end and you hit compile program. It even says on line 8, you're missing a semicolon, which is a compiler in a coding world. So you have to put it at the end of line 8. Or if you happen to forget to put this curly bracket on line 12 and you hit compile program, It says that we have some unmatched left braces, and we're going to get a couple errors showing it because this open bracket on line 6 doesn't know where to actually go with another open bracket or another closed bracket. So what I usually do is I hit fix formatting, and it kind of lines up the curly brackets for me. So see how this left curly bracket on line 8 goes with this right curly bracket on line 15, but there's nothing to go with line 6. So that's how I know I need something closed to go with it. So I'm going to just type in another closed curly bracket, hit compile program, and the error message is gone. And then I hit fix formats, and it sets it up for me, like which curly bracket goes with which curly bracket. So compile program, I want to save it since I've been playing around with it. And you can hit save here, or you can go to file and go to save. And then last but not least, you want to click download the robot, except for the fact I don't have an orange cord in right now. But once you do that, you're going to get it downloading. And once it's downloaded, then you'll have a window that comes up that you have to click start. And once you click start, you're going to then turn your Cortex on and off and unplug the orange cord from your Cortex and then see if your program works. And I can guarantee that this particular program is going to work.